Okay, over here to the right is a graph that depicts the situation. This is the axis of revolution right here, this green dotted line, y equals -3. And x equals y squared is this graph right here. And y equals x squared, I've changed that into x in terms of y, because we're going to want to get the height of this typical shell, which is going to be for each y coordinate in the interval from 0 to 1, it's going to be an x distance. So the distance from here out to here, for that y, it will be uh, the square root of y. That'll be the x distance. And uh, the distance to here, or the left-hand part of the shell, will be y squared. So the hard part, as usual, is setting up the definite integral using cylindrical shells. We're going to have 2 pi times, we're going from 0 to 1 along the y-axis, which you might have to solve these two equations simultaneously to find the points of intersection. And then here's the difficult part. Using cylindrical shells, we need the average radius, which is the distance between the center of the shell and the axis of revolution. So this little distance is y, but we want the distance from here to -3. That's going to be y minus a -3, y plus 3. And the height of the shell is going to be, well, here I have it on board too, the square root of y minus y squared. And we're going to integrate with respect to y. Okay, now how do you evaluate this definite integral? Well, you multiply these two binomials together, find the antiderivative term by term, evaluate from 0 to 1, and then multiply by 2 pi. And here's what the answer looks like in exact form, 23 pi over 10. As you can see, I get the same answer here. So I'm not going to go through evaluation of this definite integral. Hopefully you understand how to do that. And there you go. I will also include a link to the Desmos graph in my answer. If you have any questions, post a comment.